Okay, today we're going to start talking about 8.2 and applying the exponent properties involving quotients. So before it was involving multiplication and products. Today we're going to talk about quotients, which are answers to division problems. And our essential question today is, how do you use properties of exponents involving quotients? Okay, so let's first of all take a look at exponents in division. Let's take a to the fifth power, and we're going to divide that by a to the third power. So, if I expand this, we have a times a times a times a times a. 1, 2, 3, 4, 5, divided by a times a times a. Notice if I cancel, I'm left with a 1, 2 to the second power. So, with that in mind, that's going to bring me to my quotient of a power property. Now, with the quotient of a power property, what we are going to learn is that anytime I have like bases raised to exponents that I'm dividing, I simply am just going to subtract. So, like for instance, if I have 4 to the 7th power divided by 4 to the second power, that's going to be equal to 4, 7 minus 2, which is just 4 to the 5th power. So, not hard. So, let's look at our examples. Here we have 8 to the 10th power in example 1. And once again, well, we're on page 495. In case you're not there, should always be with me. 8 to the 10th power over 8 to the 4th power. That's going to be 8, 10 minus 4, which would be 8 to the 6th power. Or, how about if I have negative 3 to the 9th power over negative 3 to the 6th power? That would be negative 3, 9 minus 6, or just negative 3 to the 3rd power. You just simply subtract. Let's go ahead and take a look at C. Now C, we're actually incorporating two different properties here. Okay, so with C, I have 5 to the 4th power times 5 to the 8th power divided by 5 to the 7th power. Well, the first thing that I am going to do is I'm going to take care of this property here, which is our power of a product property. And we're going to say 5, 4 plus 8 over 5 to the 7th, which would be 5 to the 12th power over 5 to the 7th. Then we're going to subtract 12 minus 7, which will equal 12 to the 5th power. Okay? And then in D, we have 1 over x to the 6th power, or excuse me, 4th power, times x to the 6th power. Well, remember, anytime I multiply a whole number times a fraction, it's the same as multiplying the numerator of that fraction times the whole number. So it's going to be 1 times x to the 6th, which would be x to the 6th over x to the 4th. Then we simply subtract 6 minus 4, and that equals x squared. Okay, so what we'll do is tomorrow we will go over the guided practice that goes along with this. I'd like for you now to turn over to page 496, and we're going to talk about the power of a quotient property. Okay, so this one is the power of a quotient property. Let me just write that up here. Now, with the power of a quotient property, what we're going to do is when we take an entire fraction, such as like a over b, and it's in parentheses, and we're raising the entire fraction to a to the m power. So it would be a to the m power over b to the m power. It's really quite simple. So like for instance, if I have 3 over 2 to the 7th power, that is equal to 3 to the 7th power over 2 to the 7th power. Okay, so everything in the parentheses gets raised to that power. Now let's look at example 2. We have two examples, 2 and 3, that goes along with this. In example 2, we have x over y raised to the third power, so that's going to be x to the third power over y to the third power. And then in B, I have negative 7 over x raised to the second power. Okay, so that is going to be negative 7 to the second power over x to the second power. And if we go ahead and evaluate this, it would be positive 49 over x squared. Okay, because anytime we square a negative, it equals a positive, so our answer would be positive. Now, let's jump down to example 3. Here we're going to see that this does get a little more involved. Okay, so here we see 4x squared over 5y, and we are raising that to the third power. So everything gets raised to the third power. 4 to the third power, and what do we do with exponents when we raise them to powers? We multiply them. So that would be x to the 6th power, okay, over 5 to the third power, and then y to the third power. And then if I do evaluate this out, it's going to come out to equal 4 to the third power is 64, x to the 6th power, 5 to the third power is 125, y to the third power, okay? And then B, I have in parentheses a squared over b raised to the 5th power. Once again, oh, and then we're multiplying that by 1 over 2a squared. Okay, so what I'm going to do, always work out your parentheses first, so we're going to go ahead and take care of this. So it's going to be a to the 10th power over b to the 5th power. Now we're going to multiply that by y, or 1 over 2a squared. Well, we know that that's going to be equal to a to the 10th power over b to the 5th power, or let's go ahead and multiply it, 2a squared b to the 5th power. But we're going to deal with these 2a, so I'm still going to subtract the exponents here. So it would be 10 minus 2, so that's going to cancel, and we're going to subtract 2. And that will make that a to the 8th power over 2b to the 5th power. Okay? We will work the guided practice together tomorrow on page 497. Now I'd like for us to go ahead and look at example 4 together. Fractal tree. To construct what is known as a fractal tree, begin with a single segment or just a trunk. Okay, so we just begin with the trunk. This is step 0. Then, with step 1, the trunk we think is 1 unit long. Add 3 shorter segments that are 1/2 of the unit long. Okay, so for step 2, half the unit, half the unit, half the unit. I'm just estimating here. Now, for our next step, we're going to continue on. We're just going to add another half a unit here, half, 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 with that one. And then we're going to continue to proceed on doing this with every one. So we see what's happening here. One in the book probably looks better than mine. Okay, so we're adding on half units, and I could continue on with this. This could go on infinitely. But we're going to make a table showing the number of new branches for each step. So here we went from step 0, and then with step 1, 2, and 3. I didn't break mine up. They are broken up in the book. How many times greater is the number of branches added to step 5? Okay, so we see here with step 1, we went from 1 branch, or from 0 branches, to 3 branches with our first step. So we know we just drew out the 3 branches. Then in step 2, we went 3 squared, okay, which would be 9 branches. Step 3, we see here we went 3 cubed to 27 branches. Step 4. We went 3 to the 4th power, which is 81 branches. Then if you have your graphing calculator, you can just type in 3, raise that to the 5th power, and we would see that we would come out with, I think they're wanting how many branches we would have. Hold on, I have to get my graphing calculator. There it is. 5 raised to the 5th power. 3 raised to the 5th power. And we get 243. So we see it really starts taking off. Step 5, though, the new number of branches added to step 2 is 3 squared. So the number of new branches added, okay, we want the number of new branches would be 3 to the 5th divided by 3 squared. Now, because what it is asking here is the number of new branches from step 2 to step 5. So I missed that, and I apologize. So that would be 3 to the 3rd power, or 27 new branches. So they're wanting the number of branches from step 2 to step 5. And I know I messed that up. We will go over the guided practice again on that one tomorrow. Okay, I'm going to stop there. We will cover example 5 in the next video whenever we move on to the next video, because this is a 2-day lesson. Remember, your assignment is not due until Thursday afternoon. Okay? All right, you have a good evening.